All right, so get this, okay? Proxima B, our closest exoplanet neighbor. We thought we kind of knew it, right? Like, okay, it's there, probably rocky, maybe in the habitable zone, but
Yeah, but the James Webb Space Telescope just dumped a whole treasure chest of new data on us, and
and I mean, treasure chest is right because this stuff is like mind-blowing, okay? This isn't just like, oh, we learned a bit more kind of stuff. This is like completely flipping the script on what we thought about Proxima B.
it really is. And the thing is, the data from Webb, it was so complex that even our best supercomputers, like the top-of-the-line stuff, were choking on it. They couldn't make heads or tails of it all.
It's almost impossible to imagine, right? Like having all this incredible information, but not being able to decipher it. But hold on, because this is where it gets really, really cool, right?
Right. So along comes this game changer, this total rock star of technology, quantum AI. Okay, it's like this fusion of quantum computing with good old-fashioned artificial intelligence. And this quantum AI, it did what everybody thought was impossible. It actually dove into that data tsunami and pulled out like these mind-blowing secrets about Proxima B.
And for you listening, I mean, think about it. We're talking about a whole new understanding of a world that's right next door, cosmically speaking. I mean, it's practically in our backyard. And today, well, that's what we're going to do, right? We're going to unpack all these incredible discoveries about Proxima B, and we'll dive into the tech that made it all possible.
And you know, what's even more exciting is that this is not just about Proxima B. This is a glimpse into the potential of so many other planets out there in the galaxy. And now we have the tools to really start exploring them in ways we could only dream of before.
Okay, so let's get right to the good stuff. What were the wow moments that quantum AI uncovered about Proxima B from this Webb data? First up, the atmosphere, right? So we thought it was pretty quiet up there, maybe some basic stuff going on.
Yeah, well, turns out there's these wild methane fluctuations happening, a regular pattern of methane levels going up and down. And our regular analysis completely missed it. It was like buried treasure hidden in a ton of noise.
Okay, so methane going up and down, so what?
Well, think about it. Right here on Earth, when we see those kinds of rhythmic changes in methane, it's often because of, well, life, biological activity. Now, hold on. We're not saying we found aliens on Proxima B, but this detection, I mean, it's a big deal. It shows how incredibly sensitive quantum AI is.
Absolutely. I mean, it makes you wonder what other subtle signals might be hiding in all that data we have from other exoplanets. And Dr. Sarah Seeger, he's a real pioneer in exoplanet atmospheres from MIT, She nailed it when she said that these new computational methods, like these quantum-inspired algorithms, they're changing everything about how we look at exoplanet data.
Yeah.
Webb gives us this incredible detail, but without the right tools, it's like having a high-def picture, but you can't quite focus it.
Yeah, exactly. Dr. Seeger really emphasized that point. These techniques are letting us hear whispers, tiny whispers, in the data that were completely drowned out before. It's like we suddenly got these super-powered hearing aids for the universe.
Okay, so that's one wild thing, the methane. But there's more. Quantum AI didn't stop there. It also found that there are clear seasonal shifts in Proxima B's atmosphere. And get this, the seasons on Proxima B are super fast. They happen every 11.2 Earth days. That's because that's how long it takes Proxima B to orbit its star.
And think about this. What's even more mind-blowing is that the carbon dioxide levels on the planet are actually rising and falling in sync with that super fast year. What that suggests is that there's a global atmospheric circulation happening on Proxima B. Even though the planet is probably tidally locked, with one side always facing the star, it looks like heat and chemicals are being spread all over the planet.
And that is huge, right? Because early on, everyone thought the day side would be this scorching desert and the night side, well, an icebox. But if there's this atmospheric movement, it means temperatures could be a lot more moderate across the planet, and the habitable zone might be way bigger than we thought. So more places where life might be possible.
Exactly. And this is really exciting, maybe the most exciting part. Those atmospheric cycles, they point to the possibility of evaporation and precipitation, which means, a water cycle. Quantum AI figured this out by spotting all these subtle interconnected changes in different wavelengths of light. Changes that looked kind of random on their own, but when you put them all together, they form this clear, repeating pattern. And that makes it a lot more likely that there's actually liquid water on the surface, at least in some areas.
So we've got the methane thing, we've got these super fast seasons, and Proxima B is already looking a lot more Earth-like than we ever imagined. But hold on tight, because the Webb data also had something to say about surface temperature. And this is where things get super weird and totally challenge all our old models.
Yeah, quantum AI found these thermal hotspots on Proxima B's surface, And they're all bunched up along the terminator line, that zone between the day side and the night side. And here's the thing that's really crazy. Those hotspots are way warmer, up to 15 degrees Celsius warmer than the surrounding areas, and that completely throws off our climate predictions for a tidally locked planet. Before this, all we saw was this gradual change in temperature from the hot day side to the cooler night side.
So instead of this smooth temperature gradient, we've got these warm patches in the twilight zone. How in the world did quantum AI even pick that up?
Well, the key is that it can process tons of infrared data from different wavelengths all at the same time. And on top of that, it can filter out all the glare from Proxima Centauri, which is no easy feat. It's a computational monster. It's basically like it could see right through the starlight and spot those temperature anomalies, no problem.
And of course, all this has sparked some pretty heated debates among scientists, right?
Yeah.
About what could be causing these hotspots. We've got Dr. Guillem Anglada Escude. He's the one who actually discovered Proxima B in the first place. And he thinks maybe it's geological activity, like volcanoes, releasing heat from inside the planet.
Yeah, that's a pretty compelling idea. Then there's Dr. Victoria Meadows. She thinks it might be because of thermal inertia in certain surface materials. Basically, some types of rock might hold on to heat better on the day side and then slowly release it in that terminator zone, creating those warmer patches.
And then we've got Dr. Abel Mendez. He's from the Planetary Habitability Laboratory. And his idea is, well, it's the most exciting one if you're rooting for life. He thinks it could be large bodies of liquid water, like lakes or seas, that act like these giant thermal reservoirs. They soak up heat and then release it, keeping those areas warmer. And that would be a total game changer for the possibility of life.
Yeah, that would be huge. Each of those hypotheses is plausible, and to figure out which one is right, well, we need more observations. And luckily, there's more coming. We'll get to that. But those hotspots add another layer of mystery and another reason to think that Proxima B might actually be habitable.
Okay, so we got atmospheric surprises, we've got these thermal hotspots, but you also mentioned something about an electromagnetic signature. Is this the most shocking discovery of all?
It really could be. For years, one of the biggest worries about Proxima B being habitable was all the stellar flares coming from Proxima Centauri. It's a pretty active star. And because Proxima B is probably tidally locked, people were worried it might not have a strong enough magnetic field to protect itself.
Right, because those flares, they can be brutal. They can just strip away a planet's atmosphere and turn it into a barren wasteland.
Exactly. But get this, the quantum AI looked at the electromagnetic data and found evidence of a pretty substantial planetary magnetic field. And it might even be strong enough to deflect those nasty solar winds and protect the atmosphere. The AI found these subtle patterns in the light passing through Proxima B's atmosphere, patterns that show it's interacting with a magnetosphere. So, a shield, basically.
Now that is good news. Dr. Natalie Batalla, she's a really important scientist from the Kepler mission. She's been saying how crucial a magnetic field is for planets around M-dwarf stars like Proxima Centauri. Those stars are known for their flares,
Yeah.
So yeah, this finding really boosts Proxima B's chances.
Yeah, she's spot on. But there's always a but, right? Dr. Funtian from the Chinese Academy of Sciences, he's got a point too. He says even with a magnetic field, Proxima B is still getting slammed with 400 times more X-ray radiation than Earth. So that magnetic shield needs to be super strong if it wants to keep things safe for life, at least life as we know it.
So it's like having a shield, but it's constantly getting bombarded with these super powerful particles.
Yeah, that's a good way to put it. But hey, Dr. Lisa Kaltenegger, she's the director of the Carl Sagan Institute. She's got a more optimistic take, which is worth thinking about. She says, a magnetic field opens up all kinds of possibilities. Maybe there are life forms out there that we can't even imagine, life that can handle these harsh conditions. Just think about all the extreme places here on Earth where life thrives, like in the deepest parts of the ocean or those freezing ice sheets.
It really makes you think, doesn't it? Could that magnetic shield, along with all this evidence for maybe liquid water and this crazy active atmosphere, could it all have given life a chance to take hold on Proxima B, over billions of years? It's starting to feel like a real possibility.
It does. And even if we can't say for sure that there's life on Proxima B, well, at least our understanding of the planet has totally changed. It's not just a maybe habitable rock anymore. It's this complex, dynamic world. And that makes the search for life beyond Earth a whole lot more exciting.
Absolutely. Okay, so we've covered all these incredible discoveries. Now let's talk about the brains behind it all. How did this quantum AI manage to pull those faint signals out of all that cosmic noise? I mean, what is quantum AI anyway? Can you break it down for us?
All right, so at its core, quantum AI is this wild mix of quantum computing and AI algorithms. In a regular computer, information is stored as bits, which can be a 0 or a 1. But quantum computers, they use qubits. And these qubits, they can be in multiple states at the same time. They can be 0, 1, or a mix of both all at once. This crazy concept is called superposition.
Okay, wait, hold on. So instead of going through possibilities one at a time, a qubit can check out lots of possibilities all at the same time.
Exactly. And that's a game changer when you're trying to analyze these massive data sets that come from the James Webb Space Telescope. Quantum AI can explore tons of potential solutions and find those subtle, complex correlations way, way faster than regular computers that have to plod through everything one by one.
I get it. And Dr. John Preskill, he's a quantum computing guru from Caltech. He explained it perfectly. He said that quantum algorithms are superstars at finding hidden relationships in big, messy data sets. Things that might take our best supercomputers months or years to figure out, these quantum systems can crack in days or even hours. So faster discoveries, basically.
And Webb is definitely serving up those big, messy data sets. It's got NIR spec, the near-infrared spectrograph, which is like this super sensitive nose that sniffs out the chemical makeup of exoplanet atmospheres. And then there's MIRI, the mid-infrared instrument, which is like a heat-seeking missile, giving us those amazing thermal images, and that's how we found those hotspots in Proxima B. MIRI can pick up these tiny temperature differences from trillions of miles away.
It's mind-boggling how sensitive these instruments are. But all that amazing data comes with a lot of background noise, right? From all kinds of cosmic stuff and, of course, Proxima Centauri shining like a spotlight.
Yeah, filtering out all that noise is a computational nightmare. Before Webb, when we tried to study Proxima B's atmosphere with things like Espresso and Hubble, we were really limited by how much data we could collect and how well we could process it. Dr. Nicole Lewis, she's a JWST scientist at Cornell. She put it really well. She said trying to study Proxima B before Webb was like trying to see a firefly next to a giant spotlight from miles away.
So Webb gave us the ability to actually see the firefly, and quantum AI gave us the tools to really understand what it's doing, right? So how did this quantum AI approach things differently? How did it tackle all that data?
Well, instead of looking at each type of data separately, the spectroscopy, the thermal images, the electromagnetic stuff, the quantum AI built this massive multidimensional model that combined everything. And that was the key because it let the AI see these connections between measurements that look totally unrelated.
Can you give an example of how that worked, like how it led to something new?
Sure. When you're looking for methane, traditional analysis would just focus on specific absorption features in the light. But the quantum AI, it also looked at how those features changed over time, and it looked at how they were connected to other things in the atmosphere, like carbon dioxide. And that's how it spotted those cyclical changes in methane levels, which is what pointed to the seasons. The patterns were always there in the data, but regular computers just couldn't handle all those complex relationships.
So it's like the quantum AI could listen to a whole orchestra playing and still pick out the sound of a single instrument.
Yeah, a perfect analogy. It could hear the harmonies and the counterpoints that were lost in the noise before.
Okay, so we've heard about all these incredible discoveries. Now, what does it all mean? What's the big takeaway and what's next?
Well, for you, the bottom line is that Proxima B is way more dynamic and potentially habitable than we ever thought. The methane fluctuations, the seasons, those crazy hot spots, and that magnetic field, it all points to a world where liquid water might exist, and maybe even life.
And it sounds like NASA's all in on this, right? They've given a lot more time on the James Webb Space Telescope to study Proxima B.
Yep, they've set aside another 200 hours of web time over the next 6 months just for Proxima B. So we're going to get even more detailed data for the quantum AI to chew on, and who knows what else we'll find. It's pretty exciting.
And the quantum AI itself, it's evolving too, right?
Oh, yeah. Big time.
Right.
NASA and other research groups are working on even better quantum AI systems, specifically designed for analyzing exoplanet data. They should be up and running next year, which means even more amazing discoveries, not just for Proxima B, but for all the exoplanets Webb's looking at.
And Dr. Jessie Christensen, she's from NASA's Exoplanet Science Institute, she said it best, we haven't found aliens yet, but we have found a planet that seems a lot more friendly to life than we thought. And for you, that means we need to rethink what makes a planet habitable, especially around red dwarf stars, which are like everywhere in our galaxy.
And think about this too, because this quantum AI, it's so good at finding hidden patterns. Well, astronomers are now going back and reanalyzing data from other exoplanets. There might be all these secrets hidden in data we thought was boring, just waiting for quantum AI to unlock them. So yeah, this could be a whole new era for finding worlds beyond our own.
It really feels like we're on the edge of something huge here. It's all thanks to this awesome combo of super advanced telescopes and the power of quantum computing.
Absolutely. And our little trip to Proxima B today, it just shows how much potential these technologies have when they work together. It's like our closest exoplanet neighbor turned out to be way cooler and weirder than we ever imagined.
So, as we wrap things up here, I think we have to ask, what does all this mean for our understanding of what a habitable planet even is? With those crazy atmospheres, maybe liquid water, those weird surface features, and a magnetic shield. What does it all mean for life out there? And what kind of crazy, unexpected life forms might be out there in those bizarre environments across the universe? Something to think about, right? And thanks for joining us on this incredible journey.
My pleasure.